All right, the last thing we are going to be talking about today, this is on our last page of our notes, is the intermediate value theorem. So this says, let f be a polynomial function with real coefficients. If f of a and f of b have opposite signs, then there is at least one value of c between a and b for which f of c equals 0. That means that the equation f of x equals 0 has at least one real root between a and b. So what the heck does that actually mean? That is what we provided you these lines for. In other words, this means if your outputs, your y values that you solve for when you plug in a and b, go from positive to negative, or the other way around, or negative to positive, then the graph of f of x has to cross the x-axis somewhere between those 2 points. So really, this means we have an x-intercept. The important thing here, and you'll see when you go onto the website to take a look at the notes solutions, there's lots of extra information that I've written on the notes pages that you might want to include. You'll see some extra stuff in there, but really what this means is that we don't care what the x-intercept is, we just care that it's there, that it exists. So we're going to take a look at this example that says show that the polynomial function has a real 0 between -3 and -2. Take notice that this is going to be a quiz or test question, maybe both. We probably won't ask you to show that there's a real 0, but we might ask you to evaluate f of -3 and f of -2 and then interpret those results. Determine whether or not there is an x-intercept between them. So in order to do this, the kind of work we're looking for, I'm going to start by plugging in -3 every single time we see an x. So -3 cubed minus 10 times -3 plus 9. And we're going to go ahead and follow our order of operations here. That is -27. We can go ahead and do -10 times -3, positive 30. Plus 9. 3 times -27 is -81. When I add 30, I get -51. Plus 9 puts me at -42. So I would say that f of -3 is -42. I'm going to do the same thing with f of -2. Replacing every x, this time with a -2. So remember, -2 cubed is going to stay -8, positive 20 plus 9. So -24 plus 20 plus 9 means we are looking at, oops, almost looks like a 9, positive 5. So again, we have a detailed explanation of this on the notes page that can be found on the website. But what this means is that because I have opposite signs, I have a sign change, I'm going from a negative to a positive, there is only one way for me to get there, and that would require me to cross through the x-axis. I'll just show you a quick little picture to help us visualize this. Notice that -3 and -2 are actually right next to each other. So negative 3 has an output way down here at negative 42. And by the time I get to negative 2, I am now at positive 5. And we know if we were to connect these dots, since negative 3 follows negative 2, there's only one way to do that. And that would mean that this graph has to cross the x-axis somewhere between negative 3 and negative 2. Again, we don't care what the value itself is, we just care that it's there. All right. Last thing we talk about before we are going to put everything together is turning points. Turning points are actually pretty simple. If a polynomial function has degree n, then the graph has at most n minus 1 turning points. So if you think about a function like x squared, there's a reason that there's only that one singular turning point. X cubed, a lot of times, will look like this. We can only have 2 turning points. So what this means, let's say you have an x to the 4th, which can have at most 3 turning points. It's going to be very obvious if you draw a graph that looks like this, that you don't actually know how many turning points there are. So don't do something like that on your test, okay? This is just another thing to keep in mind, another tool that we're adding to our toolkit to help us be able to successfully graph these. So let's take a look at this first one. You are going to have 4 of these that you'll be doing on your own on your homework. So let's start by talking about the degree of this polynomial. I've got a power of 2 here and a power of 1 here. This is a 3rd degree polynomial, which means I should be looking for 3 possible solutions. The lead coefficient is positive, which means my end behavior is going to be falling to the left, rising to the right. Next thing that's probably the easiest for us to get started on are the zeros, since this is already in factored form. So this first factor is going to give me a 0 at negative 2. But because of the power on that factor, it has a multiplicity of 2, which means that it touches at that point. So I'm going to go ahead and plot that first point at negative 2, and I'm going to put a little t next to it as a reminder that I am touching at that point. Sometimes it's also nice to draw in your end behavior so that you kind of know where you're starting and where you're ending. The second 0 comes from this other factor, x equals 3. That factor has a multiplicity of 1, which means that I am crossing at that point. So I'm going to put a little c here. The last piece of information that's usually really helpful for us is the y-intercept. And we get that by plugging in 0 for x. If I do that, I'm going to have 2 squared and then a negative 3. 2 squared is 4, times 2 is 8, times that negative 3 means we actually have a y-intercept way down here. Somewhere down here at 0, negative 24. That's going to go off of our graph, so we're not going to worry too much about graphing that. And keep in mind that there is really only one way for all of these points to connect and work with the end behavior. So starting down on the left, I am going to come up and approach this x-intercept. I'm going to touch it and bounce back off. And I'm going to kind of leave a space here since we know that our y-intercept is somewhere down here. And I'm going to pick it back up on the other side and cross through and draw my arrow. So my graph is going to look something like that. Let's take a look at this very last example. I'm noticing that it's in standard form. I can see that I have a 3rd degree polynomial. So again, I'm looking at 3 solutions, but also thinking about these turning points, no more than 2 turning points. Because it's in standard form, I'm going to go ahead and factor out a GCF. That's going to leave me with an x minus 3 because that's going to help me see my zeros a little easier. The lead coefficient in both forms is positive 1, which means my end behavior is actually going to be exactly the same as our last example, down on the left and up on the right. Now that we have this factored, my zeros or my x-intercepts, I have to consider this one out front. Anytime we have an x out front, gives me a 0 at 0. That is right at the origin. It has a multiplicity of 2, which means it touches at that point. That is going to count for 2 of my 3 solutions. My other solution is at 3. This one has a multiplicity of 1, so I know that it crosses. So I'm going to plot my point at the origin, put a little t next to it because it touches, and then at positive 3, a c because it crosses. My end behavior starts down, ends up, and then let's go ahead and take a look at our y-intercept and see if that's enough for us to go ahead and graph this. Little trick here, if you have an x-intercept at 0, that also counts as your y-intercept, which means I really need to figure out what's happening in this area. I know that my graph is going to come up like this. I know that it's going to touch and bounce off, but then the question is, how far down do we go between 0 and 3? So I'm going to ask that you do some test points here. And if you're doing this on your homework or on a quiz or test, just make sure you show us what that looks like. I'm going to test f of 1, and I'm also going to test f of 2. Nice basic equation for me to plug this into. If I plug in 1 for x, I actually get an output of -2. That gives me the ordered pair 1, -2. That's a nice, neat point I can go ahead and plot right here. If I plug in 2, I end up at -4. So there is a second ordered pair for me. So I know I'm probably not going to go much past that -4. And now it's just a matter of connecting those dots, crossing through this intercept, and finishing up here. So like I said, the rest of class time is going to be yours to work on the homework. Feel free to work with one another in your groups during class, and there will be solutions made available to you. So do your best on this, show all of your work, and know that you're going to have 4 of these graphs all together that you're going to be doing, a couple problems that you might be working backwards from, but do your best and good luck.